Algebra 9.3 deals with simplifying radicals. So this is a little bit we went over in class after 9.1. So in order for us to take a number outside from underneath this radical, the square root sign, I have to have two of the exact same numbers being multiplied together on the inside. Every 2 on the inside, every set of twin numbers becomes 1 on the outside of the radical. Okay? So for example, square root of 20 is, I can separate it with 4 times 5. Which means that even though I have square root of 5 that is not a perfect square, root 4 is a perfect square in the sense that it's the same as root 2 times 2. I have a set of 2 that I can bring out that becomes a whole number. Now since this 5, there's no perfect square in there, and a perfect square again are numbers that perfectly square root without a decimal. So I leave that here. So root 20 can be simplified with 2 root 5. Okay? In this right here, there's different ways I can solve this. I could break this down as 5 times 10, okay, which would give me, I can also break the 10 down further into 5, and then the 10 could be 5 times 2. And this set right here of 5s I can take outside, so it represents 1 on the outside, but I still have 1 left over. So I end up with root 2. So it's simplified to 5 root 2. I could also do 2 times 25. Right? And then 25, root 2 can't be square root, but root 25 can be the same thing as 5. This turns into 5. So then this is left over, root 2. So whichever way I do it, 5 times 10 or 2 times 25, it's a slightly different process here, but at the end I still get 5 root 2. So you just have to take the number on the inside and start breaking it down to its multiples. You can do the same thing here in the sense that you can treat the top as 2 different radicals. Okay? Because a over b equals the square root of a over the square root of b. So I can do square root of 9, which gives me 3, and the square root of 25, which gives me 5. So my answer is 3 over 5. So in this sense right here, I can do it too. I can focus on the top and use the product property for root 32 and use the product property for root 50. Now I've already done root 50. It simplifies to 5 root 2. So let's focus on 32. Well, 32 can be the same as 4 times 8. Okay? Actually, 16 times 2. Well, 16, the root of 16 can be the same thing as 4. And this is left over. So 4 root 2 over 5 root 2. Now, you see this root 2 and this root 2? Well, because they're exactly the same, I can cancel out. And I end up with 4 over 5. Right? Go ahead and write that down. We're going to go through some more examples just to make sure that you understand it and don't forget your vocabulary. Alright, so when they're saying that they want you to simplify this in the simplest forms, that means you have to follow 3 rules. The first rule is there's no perfect squares in the square root. So if I can still keep square rooting, if they're still twins on the inside of the radical, I haven't done my job. And then I can't have a fraction in the square root. Alright? And the last one is if I have a square root in a fraction, because there's a difference. Here is a fraction in the square root, and here is a square root in the fraction. Okay? So if I have a square root in the fraction, I can't have it in the denominator. So I can have something like this, but I can't have something like this. Alright? And I'll show you in a little bit how we get rid of that. So let's look at 98. So 98 is kind of a number that I don't know the multiple, so I'm just going to start with 98 divided by, let's say, 4. Nope, that gives me a decimal. So I'm going to go 98 divided by 2. Which gives me 49. So this is 49 times 2. Well, root 49 is the perfect square. Root 2 is not. Root 49 is the same thing as 7 root 2. And that's my answer. There's no perfect squares, right? I can't take anything else out from the square root. There's no fraction in the square root, and there's no square root in the denominator. Okay, let's do 63. 63 divided by, let's say, 3. 21. So square root of 3 times 21. Okay? I can't take anything out yet, but I know that 21 can be reduced to 3 times 7 times 3. Okay? So this and this I can take out, making 3 on the outside, but the 7 is left over, so I'm going to keep that in there. And that gives me that answer. Okay? Number 3, because I have a fraction, I'm going to do what I did the last example. I'm going to have 80, square root of 80, over square root of 45. And then I'm going to use the product property on both of them separately. Square root of 80 is the same thing as 8 times 10, which is the same thing as square root of 4 times 2 and 5 times 2. Okay? So this means 4 is a perfect square. Could be 2 on the outside, right? This 4 is 2 times 2, and then I have everything else times 2 times 5 times 2. So, because of this, I have one set of 2's that go on the outside and another set of 2's that go on the outside. So I have 2 2's that I can bring out and root 5. So 2 times 2 is 4 root 5. Okay? But that's only square root of 80. Now I have to do square root of 45. So the square root of 45 is the same thing as the square root of 9 times 5. Right? Well, this can come out to 9 is the same thing as 3 times 5, right? I bring the 5, and so I end up with 3 on the outside and 5 on the inside. So my answer is, let me put in another color so you can see, this over this. So 4 root 5 over 3 root 5, these cancel out, giving me 4 over 3. Sorry, that's a little messy, but this goes for this, and this goes for this, and then I put it together at the end. Since root 5 is the same, I'm left with 4 over 3. Alright, let's see if we can be a little bit more organized in this next one. Okay, I'm going to do, again, split the radical. So root 5 on top and root 12 on the bottom. Root 12 can be root 4 times 3. This is a perfect square, root 4, which is 2, so it's root 5 over 2 root 3. Everything is simplified in this case. The only problem is the last rule says there's no square root in the denominator. And I have a square root down there. So what I'm going to do now is I'm going to multiply the top and bottom by that root. Root 3, root 3. I can multiply anything that I want with these and keep it with a fraction and keep it balanced. I just have to make sure whatever I multiply to the top, I have to multiply to the bottom, right? So I haven't changed anything. So this becomes root 5 times root 3, which is root 15. right? And this root 3 and root 3 cancel out. Well, not cancel out. 2 times root 9. Well, I know that root 9 gives me 3. Square root of 9 is times 3. And root 15 is on top. 2 times 3 is 6. So I end up with root 15 over 6. Okay? So again, what I did is, this is the simplified form, but because that root 3 is there, I want to get rid of it. And if I multiply it by the same exact thing, then there becomes a set on the inside, which then becomes a whole number, if you see that. So the top just becomes whatever it needs to become, because my goal is to get rid of that square root from the bottom. So go ahead and write this down. Try page 512, number 11, 14, and 16. 512, number 11, 14, and 16, and I will see you in class.